when I was preparing for this panel, I found a study from the IEA, and those who know the IEA, they never do short studies. And they came up in April with one study that energy and AI in April 25, 304 pages. This is not really my bedtime reading, and I don't think a lot of people will read that. Fortunately, they are doing a very nice executive summaries from their studies. But that one was too long, and I could spend the 45 minutes reading the executive summary, but I just retained a few statements from that study because I think it sets the table well for what we're going to talk about with this panel. A typical AI-focused data center consumes as much as 100,000 homes, 3 little dots, but in the future, they will consume 20 times more than that. So that means 2 million homes for one data center. It's like the city of Montreal. I find it a little bit strong, but even if it's half of that, it still means that there's going to be a huge increase for electricity demand worldwide. According to the IEA, this demand will be met by renewables, partly. It will need short lead times for new supplies. We're going to talk about that. It will be driven by economic competitiveness. This is very reflective of the situation here in Quebec, where the government is stacking project on top of another and then deciding who's going to get the megawatts needed for their projects in AI or data centers or other economic sectors. There's going to be a bottleneck at some point. It will need procurement strategies of tech companies, as one of the panelists will talk about that. And globally, natural gas, nuclear, even deep geothermal will play a role in supply and influence the localization of data centers, and so on and so on. So there were zillions of things in that study. Those interested, read that and then call me so we can discuss. So I invite now the panelists to come on the stage. And while they are doing that, I'm just going to comment on the title of the panel. So, Innovating for Digital Sovereignty, the Future of Data Center. And yesterday I thought we should revise this title for the future of decentralized energy and data centers. And while they are still coming on the stage, there we go. If we put decentralized energy in this title, it means that we have a bright future as a decentralized energy organization. And as the treasurer, the newly elected treasurer of the organization, I'm going to do my marketing pitch if you're interested in becoming members of DEC and see more events like this in the future. Don't be shy. Talk to Anouk or myself, and we'll be happy to welcome you as members. And next year you can vote to exclude me from the board. So. Okay, there we go. So I will ask each panelist now to very briefly introduce themselves, and like 2 or 3 minutes, and then we will go to the presentations.
All right, I have the mic. I'll start. So I'm Bernie Olgema. I'm the Director of Data Centers at Siemens Canada. I've been in the industry for about 30 years, more than 30 years, I think. So I think about data centers in the shower every day.
I'm Andy Fenton, Vice President Sales and Marketing for Telehouse Canada. Like Bernie, I've been in the industry for roughly 30 years, maybe 29, but a long time, so I don't think about them in the shower, but I do fall asleep many a night thinking about what to do next, so that's me.
So I'm Vincent Duval, no linked with Bernard Duval just before, but great to have two Duval in the same room. I'm head of business development and large accounts. It's more specifically, I take care of data center in Quebec. So pleasure to be here and discuss with you.
Bonjour, Quebec. I'm Jan Buick, and actually I know nothing about digital sovereignty. So I'll talk a little more about the energy part of data centers. Work for a company called AB Energy, headquartered in Italy, and we manufacture modular, containerized, gas-fueled generator sets. We can do up to 200 systems a year. That would give us about 600 megawatts of capacity that we can bring to market. Present in about 22 countries around the world, and we used to be about a $400 million a year company, and with the explosive growth in the data center space, we're rapidly going to $800 million a year organization. So we'll talk a little bit more about all the crazy energy stuff that we see happening in the data center space these days.
Thank you. Good morning, everyone. I'm Hanif Montazeri, co-founder, CEO of Enersion. Definitely not taking, I'm a newer member of the data center crowd. We have developed this, as you know, data centers, during operation of them, they produce lots of heat, or during energy generation, they produce lots of heat, waste heat. And we have developed this technology that is able to convert waste heat into cooling using nanoporous materials. So I've been dragged into the data center conversation recently because there is enormous amount of waste heat that somehow has to get utilized. So glad to be here and looking forward for the panel.
Thank you all. So let's start. The way we're going to work is we're going to get three presentations, I think, 3 or 4. 4 presentations, like very short, 3, 4, 5 minutes max. Then we will engage into a discussion. If we run out of ideas and if they don't know what to say anymore, and you're interested in making an intervention, just stand up, do a little dance to attract my attention, and I'll give you the microphone. So let's start with Bernard and Drew, who will introduce the session and talk about the reuse of waste heat, among other things.
Sure, thank you. So first, I just kind of want to give you some ideas. So Denis had some good metrics to give you some idea of the growth. Like the growth in the data center market is like off the charts. It's unbelievable. So like I said, I've been in the business for a long time. I used to think a big data center would be like BMO, RBC, TD Bank. They all have enterprise data centers. There's A, B, redundant, and biggest one was like BMO, I think 3 megawatts. Huge, right? And that then about 2 years ago with AI started to really take off, we'd see bigger and bigger ones. So 10 megawatts started to become like sort of normal. It's like, wow, that's like 3 times what I think was a big data center. So right now in Toronto, we've got an AI data center being planned right beside BMO data center. It's 400 megawatts. So just imagine, like, what is the math? 120 times bigger, 130 times bigger than what I used to think was big. And then also putting that into relative size. So Ontario announced as well, we're going to have go into SMRs, right? So we're going to build an SMR. It's going to solve a lot of problems. So they have 2 SMRs on order, 10 years to build, 300 megawatts each. It's like, well, that's less than 1 data center. And there's many of these being planned. So the scale, just to give you an idea, like this is a enormous change in the whole data center world.
Yeah, I would comment on that. So Telehouse, we build, we operate data centers, and we do it around the world. So I'm from Toronto, but in other markets we do the same thing. The demand and the use case change in the last say 36 months. It's just been that dramatic, and it's all driven by really rack density. I think that's a lot to do with it. And for those of you who aren't familiar with that, in any given data center, you've got cabinets which are stacked with servers. And back in the day, you might, when we started the industry, you would have seen rack densities of maybe 1.5 up to maybe 3 kilowatts per rack. So today now it's common to see 125 to 150 kilowatts in that same form factor, right? So that same rack, now you can push 150 kilowatts into that rack. And the only way you can do that now is to modify the cooling. Everything before used to be done by basically blowing cold air through the cabinet. And now it's all direct to chip liquid cooling, which Bernie's very familiar with.
Yeah, so actually I like to use the analogies again. So Andy was saying cabinet used to be one 1 to 2 kilowatts each. So that's like a hair dryer. And like the furnace in my house, I have a 2,000 square foot house. It's rated 24 kilowatts, and that's like you ever go in your furnace room, the thing's already like lots of heat coming out. Now we have cabinets. This is the size of a fridge. It's like 150 kilowatts. That's like 4 of my home furnaces blasting all at the same together. So it's just phenomenal. So then, yeah, like Sandy was saying, so about 2 years ago when Blackwell chips started to become popular, that's when we started seeing these 100 kilowatt cabinets. There's just no way you can air cool it. So that's where we get into liquid cooling of these data centers. And then that's where I started talking to Hanif about, hey, I got all this liquid, warm liquid coming out of these cabinets. What can we do with that heat? But I wanted to step back. One more thing is I thought it would be good for everybody to understand. So when you think of a data center, everybody thinks of just, that's where my Gmail goes or whatever, right? But there's probably, 4 to 6 categories. So in the first level, you'll have your communications interchanges, where Andy's the expert in that. And you have your enterprise, which I talked about, BMO or insurance companies and that kind of stuff, and big corporations. And then you have colos, which is where people that don't want to run their own data center, they'll rent space within a data center. You have your cloud data centers. These used to be the big ones. They're like 40 megawatts, where all your stuff is stored in the cloud, right? Which is actually on the ground. So, and then we get into Neo Cloud, which is all of our AI type workload, and your hyperscalers that also have these AI factories. So, this from like less than a megawatt to 1, 2, 3 gigawatts.
Yeah, no, I think that the point there is that I think when I talk to people about data centers, there's this common sort of misconception that they're all these giant things in the middle of nowhere that don't create jobs, and they're gigawatt campuses, because that's kind of what's been sort of in the news lately, is these massive campuses. But the taxonomy of data centers is quite different, ranging from the AI factory, those gigawatt campuses, down to what we operate, which is commonly known as a carrier hotel. So the function of a carrier hotel is that it's that very edge data center where all the fiber providers, ISPs, content distribution networks, et cetera, they all have presences within those buildings, like ours. And the building owner facilitates the interconnection of one company to another, be that a carrier to another carrier, or be that an ISP to YouTube. It's all about delivering content and making sure that the eyeballs or devices that are consuming that content are as close as possible to where that content is generated. So that sort of taxonomy, from the very large AI factory down to the carrier hotel, it's important to understand that each one of those data centers has very different attributes and different geographic locations and different power requirements. And some are more likely to require different sources of power, and some are less likely to. So understanding how all of this ecosystem works together is pretty important, because like I said, all data centers are not the same.
And then one last detail is also the AI data centers. There's typically two classes. So the big ones that, and you're talking about like 1, 2 gigawatts. You hear about like Alberta, it's getting a meta data center, which is 970 megawatts. It's going to be double to 1.8 gigawatts. That's for training. So again, when you hear about ChatGPT or Grok or Gemini, they have these new versions every once in a while. Those have been like grinding in a big data center for like 6 months. So they'll train this model, so an LLM, and then inference data centers would be like smaller, closer to the eyeballs, which require lower latency. So right now we're seeing these big, huge ones, but in the next few years, even more power is going to be used by inference data centers, which are going to have to be spread all over the continent near the metro centers.
Yeah, and I would just say largely that class of data center doesn't exist today. But if you talk to anyone from a large hyperscaler, or anyone who's company that's going to be doing inference, like a Meta, like Microsoft, etc., what they're interested in finding is those data center locations that are close to these large population zones where they can get, a 5 megawatt deployment in short order. But that, like I said, that doesn't exist today. That's a new class of data center that we're only starting to see emerge now that training is shifting to inference, and we're going to see that shift, the pace of that shift increase over the next couple of years.
Great.
Are we on time?
You're on time. Well, I don't know. It feels well, so it's just fine. So on that note, we'll now ask Vincent Michel to give us the view of a
Power utility?
utility.
All right. Just a few numbers for you. Data center-wise in Canada, and those are numbers from 2024. So roughly 760 megawatts of data center in Quebec, 650 in Ontario, 150 in Alberta, a little bit less in BC. Small numbers if you compare to a 1.4 gigawatt of one single data center that will be installed in Texas through Vantage, OpenAI, and everything else. Which doesn't mean that it won't, I mean, data center will grow in Canada. I don't think we'll see what's happening in the Texas in Canada, but data center are key to economic development. So you'll see more data, more megawatts being given, but I don't think to the extent of what we see in the States. So Bernard was talking about the grid reliability earlier on, and this is a little bit of my job to work with data center and find solutions so that we integrate what we call flexibility. So flexibility is the capacity of playing with your load, so the amount of electricity you're consuming, so that you can provide some services to the grid, so the grid stays stable. It's oversimplified, but in a nutshell, that's what flexibility is. So that's what we're trying to do, or that's what me and my team are trying to do with data center. So nowadays, energy availability is the bottleneck. If you have a project, whether it's a data center or a new plant or anything else, finding the megawatts are tough. So we have in Quebec a new process to allocate those megawatts. I won't go there because I could talk about it for 45 minutes. But with that came the obligation of, for every single new project, including data center, of bringing 30% of flexibility, 30% of demand response. So 30%, it seems like an okay number. But if you put that in data center is a large load, 100 megawatts. So that's 30 megawatts of demand response. It's huge. Data centers are working 24/7, 365 days a year. There's no flexibility in the way they consume the data, and you cannot shift the production to another day. It's 24/7. So how do we go about to do this flexibility? How can we do it? A couple of solutions. They're not easy, but a couple of solutions. First one, the obvious one, is genset, whether it's diesel, natural gas, biogas. So it seems simple, but federal laws, municipal laws, provincial laws are making it quite difficult to install nowadays. Other solutions, wind production, solar production, but we're talking about 100 megawatt loads. So imagine the size of the wind farm or the sun farm, the solar farm. The one that's working better right now is BESS, battery energy system. So integrating batteries and then using those batteries to do the demand response part of things. It's still a big infrastructure to install, but this is something that's working pretty well. And something quite interesting as well is maybe in AI and HPC is load shifting. Some entities, I won't name them, but that are global are supposedly able to shift load from one region to another without impacting their processes. So that's 8 to 10% of they can do. And finally, recreation of heat, so district heating and stuff like that. It's something that we need to work in, and it's very popular. It's very easier to do in Europe. Here in Canada and the States, it's tougher, but we need to work on how we can bring back the heat and reuse it. So yes, there will be more megawatts for data center. because it's so important for the economic development of Quebec, of Canada, and if we want to build a sovereign AI, sovereign anything, we need those megawatts. So on that, I'll pass it to
Jan. So thank you, Vincent Michel. You mentioned the bottleneck from a utility perspective. Ian has an interesting technology example, but also another type of bottleneck that will slow down maybe the supply of or the development of data center. Yeah.
I think 30% service through natural gas generators is an excellent idea, actually. To
we'll talk after.
yeah. I spent my entire career looking at maximizing efficiency. It's been really from my younger years rolling into the cogen business back in the Netherlands, looking at how can I optimize cogeneration systems and the combined production of power plus heat instead of the separate production of power plus heat. So if I then look at recent years, how things were evolving in the data center space, the first time I started to look at gas engine application with data centers was somewhere around 2019, where Microsoft had purchased about 60 megawatts worth of gas engines to be used as standby generators. It was for the first time that technology was deployed in data centers, and it was really driven by Microsoft wanting to improve the emission levels of their standby generators. So gas engines had achieved the performance capability of diesels, could start just as fast, could have the same load transient capability, and we start to see that, hey, maybe there is an opportunity for gas-fired generation in the data center space. To quickly learn that data centers were not at all interested in adding gas generation, definitely not for standby power. Why would you buy a cleaner technology for something that really never should run? Fast forward a few years, and about 2 years ago, we started to see the power crunch starting to happen, where the data center space was really starting to grow exponentially. Utilities could not deliver the power needed to accommodate that growth, and we started to see that the next phase was for data centers to locate where other sources of power were available, be it natural gas as a resource, and suddenly natural gas-fired generation became a serious consideration for providing the energy needed for data centers. So we decided to go to market with in the back of our head that you want to be maximizing energy efficiency. And if you, instead of using utility power to power your data center, if you start to shift towards natural gas as being a major source for data centers as the fuel source, the energy source, the moment you run a natural gas power plant, only about 40-45% of the energy that is being put in comes out in the form of electricity, and you would waste the other half, the other 45%. So what we developed was a concept of a 50 megawatt power block, combine that with recovering all the heat from the engines. So if you recover all the heat from the engines, you can now utilize that heat through absorption cooling to deliver power plus cooling to a data center. So with 50 megawatts worth of power generation capacity, you can create about 10,000 tons of cooling, and the net effect is that you can have an overall reduction in power demand of about 10 to 15% also results in a 10 to 15% reduction in fuel cost and associated emissions. And then furthermore, if you say, well, we want to work towards zero emission applications, you could, of course, utilize something like hydrogen, yeah, which is all the engines are potentially running on hydrogen. The availability of hydrogen is a challenge, but you can also utilize renewable natural gas, RNG. Doesn't mean that you have to ship RNG directly to the power plant. You can convert enough of your natural gas in RNG, so that you buy RNG that is injected in the gas pipeline somewhere in North America, but you buy that gas to offset gas that you burn in the power plant. And with displacing about 25% of your natural gas with this RNG, you'd effectively become carbon neutral in your operation. So there's many ways to become more efficient and carbon neutral. Unfortunately, today it's just a massive gold rush in installing power generation as fast as possible. So we do not yet see the real improvements that are possible. But I do believe that as time goes by, then these kind of efficiencies will be more and more important in the energy supply of data centers. And perhaps Hanif can build more on that conversation as well.
There you go.
Thanks, Jan. Yes, I think maybe I just to start, maybe following your conversation around the additional improvement that we could potentially add to this new development of a data centers. I think, as you have heard, I mean, as Bernie was mentioning, that the new liquid-cooled data centers are producing each cabinet and making around 110 kilowatt of heat. And that's the waste heat that right now at this point need to kind of get dissipated into the atmosphere without any use typically. And if you're making a power generation using natural gas, biogas, or even hydrogen, roughly around half of that energy in the form of waste heat from the engine block, that is around 90 degrees C. So is there any way that we could utilize all that heat and provide some benefit to the data centers or to the community? And what we have done, we have developed this nanotechnology-based chillers that basically, instead of using electricity, we are using waste heat as a source of energy. So, so what we do, we are grabbing this heat, whether it's from liquid cooling servers or whether it's from engine block, and we convert that heat directly into cooling and heating. So there are two types of application for it. Either you could return that cooling back to the data center, so then they have a reduction in terms of cooling demand for the data center, or for that matter, you are reducing the amount of natural gas that you're using to run these data center, because as Jan mentioned, is that around 10 to 15% energy efficiency gain from the technology like absorption technology. Or the second option is that you are providing this heat and cooling to the community, particularly for data centers that are located like telehouse data center that are located in the core cities, because they could provide enormous amount of heating and cooling option for the data centers for the community summer and winter. So maybe just kind of close it down on the technology that we have developed is at 90 degrees C. It potentially would be twice better, produce twice more cooling than absorption technology. And because of that, that number of 10 to 15% could be 20 to 30%. And that means that any facility around the data center could benefit significantly more about the heat that the data centers are rejecting, and in the form of cooling or heating for any operation around the data center. Maybe just stop here and then let you maybe jump for the conversation.
Thank you, Hanif. That's interesting because I'm an economist, as you all know. I've been working with engineers all my life, 41 years in the business. And what I find working with engineers and scientists is that they always have solutions for everything. But then there are barriers to bringing all those technologies to the market. Jan did not mention one of the things that we spoke about yesterday, and which is the availability of those technologies. And I would like you to spend 1 minute on that, which is another type of bottleneck, not on energy supply, but on
Factory being sold out.
factory being sold out. There you go.
Hey, it is a major issue right now. Yeah, we started to see over the last couple. Yeah, I think it's over a matter of about 2 years or so. First, large gas turbines becoming a problem, sold out for many years, and as the search for generation technology started to widen. As we entered the market in 2024, trying to get some name recognition and starting to speak at data center events, primarily in the US, it was like groups like this where this was data center specific, and hoping that people would come up to us wanting to talk about 20, 30, 40 megawatt type projects, and you get individuals going like, what would it cost to buy 300 megawatts of power from you? And I said, well, about 300 million. Okay, that's not a bad price. Yeah. So before you knew it, we were talking these mega deals, first mega deals. We've traditionally been in the 1 to 10 megawatt space as being the market where our products were being deployed, and we're now talking about 300 megawatts. That's 100 containerized generators at a single site powering data center. And we have more than one deal like that. And a few months ago, we were still looking at, yeah, we can deliver 26, 27. Today, if you say, when can you deliver? We're talking late 2028 or 2029. And I think that within the next few months, we're going to hit a point where we're sold out. Yeah, the factory that we buy engines from, Jenbacher, is sold out. A company like Oracle walked in there offering to buy the factory, so they had access to the manufacturer of generating equipment. Our factory. We started construction on a new factory last year. Should be complete by August. And as recent as yesterday, I found out that our parent company is building another factory. Yeah, so tripling the manufacturing capacity that we used to have. So it is on an unbelievable scale, but it's also on the power generation side, hitting a point where, and we're not unique, we're sold out, and then you start to think, wait, what is next? Yeah, that if all of this was driven by utilities not being able to deliver the power because it would take 5, 6, 7 years, if now the generator capacity is maxing out, so we're starting to approach this 5-year point, then what are we going to be talking about this time next year? Yeah, because that energy demand doesn't seem to be a limit to that right now.
That's a good segue to next year's conference. Where are we going? But you answered the bottleneck question and the technology barrier I wanted you to discuss. There is another barrier that I see, and I think, Andrew, you mentioned it very briefly, but it's I come from a generation where we were all excited when the 14.k modem came in, improving from 9.6 or 9 point whatever it was. Data center, they will use something else to carry the information back and forth. So we're talking about optic fibers and so on. So what's the role of telco in this whole picture, and are we facing a bottleneck as we're facing with production facilities as well?
No question that the telco or the fiber provider is a key part of it. There again, these misconceptions exist that you can just find a farmer's field in the middle of nowhere, set up a data center, and you're good to go. But the reality is that these hyperscale, these AI factories, they need three fiber paths that all go to diverse locations, sometimes four. They all have their reference architecture that demands that type of resiliency. And we're talking about higher fiber counts than we've ever seen before. So cable size of 864s are common. And today's carrier, the Bells, the Teluses of the world, they simply have not got up to speed on that. And it has lent itself to sort of a new class of carrier, or a new business model, I should say, where companies that aren't carriers that operate their own networks are happy to go in and construct these fiber routes. And they do it with a view of a 20-year return on their investment, usually financed by the data center provider or the tenant of the data center provider. So the fiber is absolutely key. And as we the shift to latency that I mentioned as well, not only is fiber going to be important, but the proximity of that fiber to a building such as ours, like you can't do inference if you're 500 kilometers from your user base. It's just not going to happen. Latency too high. So all these things come into consideration when you're planning for data center builds and the ecosystem around it.
Great. One more barrier, and whoever wants to answer, go ahead. We used to look at the electricity grid as being the base load provider for every facility. With data center, we're talking more about decentralized energy and auto production, and many people see the grid as the backup power. So it's kind of a reverse paradigm from what it used to be. And maybe this is for Vincent, Michel, and others, but personally, I don't think it's realistic to consider the grid as the backup power. So are we considering then having two decentralized energy systems to ensure resiliency of the data centers? But curious to see to hear what you have to say on that.
I mean, when data center come to Quebec, their idea is to have 99.6% renewable energy. So some of the big players, this renewable energy is still key to their business model. So having a decentralized production using gas, diesel, for some of those players, it's not an option. But for others, it is, of course. Is it feasible in Quebec? We would have to have discussion on that. If I look at a grid from a grid perspective, well, it's less of a load, but then it comes with a social acceptability, integration of this to a community, and all of those questions which are difficult to answer. So I would say it might happen right now in the States. It might happen probably in Alberta. I'm not sure in Ontario or in BC it is the same. We'll look at as things go on, but from our perspective, the way to do it is grid connected with renewable energy. And if there's somebody who wants to explore installing wind farm, solar farm, the laws are allowing it now. It's quite, you need to follow the pattern, but it is possible. But I haven't seen it, or I'm not discussing any of those solutions right now.
Okay.
Just very quickly, renewable energy is a very important part of it. I just want to kind of emphasize on something. I mean, if you look at the city of Quebec or city of Hamilton, the way they are right now getting their heating is using natural gas primarily, right? So if we do a better master planning around our cities, one other option would be, instead of the cities using natural gas to warm up their building, potentially, and given that there is no alternative solution at this point, the natural gas could go first to natural gas generators, that runs the data center, and that heat that the data center uses get pumped into the city. So community master planning is really a big key factor in this game, that we could be green with just a bit of a planning. And I think I just want to add this one quickly. Yeah, thanks.
Yeah, we're all looking at the.
Denny,
the timer.
I'd like to make a comment about the grid as backup, because that is something we actually do not see happen. If grid power is available, then that is your primary power source. We see the natural gas becoming very important because grid power is not available. We do not really see gas-fired projects where grid power is used as backup. I can see a lot of interaction between infrastructure, but the primary driver right now is that you cannot get grid power. So it's not that someone says, we have grid power, but we'll put in gas-fired generation and use the grid as backup. But that is not something we see.
So I can add a bit to that. So actually data centers are designed where the grid is the economical source of power, and then you have your diesel plant, diesel generators, is your critical source. So you have 24 hours of fuel storage. So you actually have a scenario now where you could have like a gas plant, which is feeding the data center. If it fails, we still have to have all these generators. So it seems kind of crazy. We could probably do some optimization there, and maybe with BESS or something like that. So, and the other common thing I think we're kind of trying to put a seed in everyone's head, like this forum is decentralized energy. So I want you to think thermal energy, not just electrical energy, right? So these are interconnected.
And on that note, 3, 2, 1, 0. Right on time.
Thank you.
Thank you.